Hello everyone, welcome back to Coding Tricks. So, in today's session, we are going to see 4 counters, collections in counter. So, let us get into that. So, what is a counter? What does a counter do? So, we know that counter will count the number of occurrences like that, right? Yes. So, counter is a container. It is a container which will hold the value. It is included in the collection module. So we know that with the objects or anything which will hold, it is called as a container. So in the Python, it is also the same, which holds the objects is called as a container. So it provides the way to access the contained objects and iterate over them. So the best examples of containers are tuples, lists, and dictionaries, because it will hold the values, it will hold the objects or values. So that's why this counter is a subclass of dictionary, and this is an equivalent. This collection is another collection because it is a dictionary, and it is equivalent to bag. Means it will hold different items with we can have the different items like that, right? Like it is a multi-set of other languages. And coming to the syntax, we will go with class collections dot counter, either it's tuple or mapping. You will go with tuple or mapping. And while initializing, you can go with any of the 3 following ways, which is the constructor of the counter, it can be called. So these are the 3 different ways. You can go with the sequence of items, or you can go with the dictionaries, or you can go with keyword argument mapping, like A equal to A, direct mapping. So anyways you can go. So let us take a simple example. So here I am showing you 3 ways. So with the keyword argument, and with the mapping, and with the dictionaries. So you can see here I have given print counter BBA different values. Here I have given the sequence of items I have given here. And here I have given the dictionaries. Counter A with 2, A with 3, like that I have given the dictionaries. And here I have given the keyword arguments, like that mapping I have given here. So you can see here, it will count the values. How many number of occurrences of B, how many number of occurrences of C, it will give you. B is 5, A is 3, C is 2, like this. Whereas dictionary you will get, and the keyword arguments you will get. So all the ways you can go. And you can also update the values. See, how can you update the counter values you may have in the doc, right? So first you will create an empty counter and also create an empty counter. How can you create an empty counter is, you will assign an object called any of the object, like counter. And this I have created an empty counter, and I am going to update here with this variable update of data. So whatever the data I want, here I will pass the data. So let us see with the simple example. So this is an example which I have given. So here I have given actual data is this, and I am trying to update with this value. So you can see the output. The occurrences of 1 is 1, 2, 3, 4. So you will get 1 is 4 and 2 is 3. 1, 2 and 3. And 3 is only 1 occurrence. See, when you are updating this 1 to 4, it will be increased with 1. 1 is increased 4 to 5, and 2 is increased with 3 to 4, and 4 is increased with 1. So this is how you can update the counter as well. And also you can subtract also. See here what I am going to try is, so here data can be but cannot be replaced. It can be increased. So count can be 0 and negative also. It can be 0 or negative. So here I am trying to subtract the values. So while I am subtracting, I may get the negative values also. When I am subtracting the lower number to higher number, I will get the negative values as well, right? So here I am subtracting this C1 to C2, C1 minus C2. So when I am subtracting 4 minus 10, I will be getting minus 6, and I will be getting B as 0, and I will be getting C as 6. So you can see here AC is 6, B is 0, A is minus 6. So I am calling C1 dot subtract of C2. So this is how the counter can get the 0 values as well as the negative values as well. So this is how you can update. And coming to count, so you can also count the distinct elements. So here I have given the distinct elements. Like in the before example, we have given only alphabets like A, B, C like that, right? Here I have given blue, red, blue. So like different values I have given here. So it will also count the distinct values, like how many number of occurrences of blue. So here is 3, red 2, blue 2, like that. So the number of occurrences it will give you like this. So you can also try with the new coding. So you can also see you will get one value like this. So this is how the counter can be done. So we have seen how the counter has been updated and how the counter is used with the help of collections. Next session we are going to see about ordered link, that is a part of the collections. So we will see what is an ordered dictionary and what is the difference between normal dictionary and ordered dictionary. All this we will see. So ordered dictionary is a subclass of the collections class, and the difference coming to the differences, ordered dictionary will preserve the order, like in which way we are inserting all those order it will catch. Whereas a normal regular dictionary it can't track the insertion order, and also while iterating it will take an arbitrary order like that. So that is the main difference. So let us see with a simple example. So in this example I have shown you like ordered dictionary and normal dictionary. It is just similar to the dictionary. Put it ordered dictionary, and like here I have given D equal to open brackets, and I am giving here dictionary. As for dictionary I am giving A equal to 1. That means key value pair I am giving. So for the key value pair, while you are doing, you will give like this, right? We have already said it. And B2, C3 like this I have given. And if you want to access the keys, you will write here for key in d.item. If you want to access only values, you will write here value. If you want to access both the key and values, you will write like this. We have already studied this, right? So for key comma value in the items, I want both key and value. So I'm requesting for key comma value with the help of further. And this is an order dictionary. Here I'm giving the order dictionary equal to order dictionary. And for order dictionary, I'm giving try with the help of output what you will see. So you will see that dictionary and order dictionary is having the same values. A is 1, B is 2, C is 3, D is 4 like this. So when you will see the changes, when you are going to update or when you are going to insert the new items, then you will see the changes. So let us see that. So first thing is key value change. That means when you are changing the key and value, or when you are changing the value of that key, at that time the key will be remaining as it is, and you will see change in the value. So for that I have written a simple program. So you can see here. So here I am giving here OB of C equal to 5. I am updating the value. I am changing the value. I am keeping key as it is, and I am changing the value. So you can have a look here. So see here, A is 1, B is 2, C is 3, D is 4. This is beautiful. And after when I have changed, C became 5. This is the updation. So if you want to delete or if you want to reinsert, it is also possible. How we can do that? You can see here. So here what I am doing here is I am popping off C. I am popping C. C equal to 3. That means I am deleting this C, and I am again reinserting the value C. So you will see the change here. So in the normal dictionary, we don't know where it will appear, but in the order dictionary, you can see here. So this is before deleting, it will remain all the same as it is, and after deleting, you will not see C3, and after reinserting, you will see here C3 in the down, because here it is already filled A1, B2 and B4. So this is how you will we can reinsert, we can delete with the help of order dictionary. And so some more we should consider this, and what is that is, before 2.7 versions of Python, order dictionary will consume more energy because it will apply. This is due to double A linked list. So where we will see this double A linked list is the data structures. We can see this double occupies more memory, and after 2.7, in Python 2.7, order dict is not a subclass. It is not dict subclass. It comes from collection module. And starting from Python 3.7 and in later version, we have guarantee of Python dictionary that it will save in a particular order, and this order dictionary will use tag to help the pop item or to delete the items. Tag will be used. Stack is nothing but last in first or last. That is what stack. We are going to see about default dict. So default dict, it is one of the module in collections. So it is from the collections module. Let us see what is default dict and how it can be used. So default dict, it is called as default dictionary. So we know that dictionary in Python, it is an unordered collection, right? So it will store like a map, we cannot expect where it will store if we are going to update the value or insert the value. So we don't like. So it is like a map, we can say that. Unlike other data types, this will also hold a single value as an element. Dictionary will hold key value pair, like we will provide the key as well as value, right? So in dictionary, we should have the unique key. The key should be unique and it should be immutable. Whereas in Python tuple, so it is, we know that dictionary is, we will give key and value and it should be unique and immutable, right? That means that we can say that the Python tuple, it can be a key, whereas a Python list cannot be key, like that. So we can also provide number of elements in the dictionary like this with the help of a comma, separating with a comma like this. So let us see a simple example demonstrating the dictionaries. So in this dictionaries, if we are accessing the value key only, right? But I'm trying to access the dictionary value of 4. I did not give the value of 4, right? So I'm trying to accessing that. So at that time, what error will cause? It will cause save. So we will get a key error, right? So in the dictionary, we will get key error if we are accessing the value which is not present. So if we are removing this or if we are commenting this, you will get the output. So see here. This is how we will get the output. So if we are giving the default, if we are giving the element which is not present, then we will get key error. So in the default dictionary, in order to overcome this key error, we are using the default dictionary. So what we will give in the default dictionary to overcome that? Let us see that. So in order to this default dictionary is a container which is present in a collection module. Default dictionary, we can also tell that it is a subclass of the dictionary which returns dictionary object, and it will default dictionary never raises a key error. That is one benefit here. What is the syntax and how we will give the default dictionary is, we will write like this: default dict. We will give a parameter as default factory. So what is this default factory? We will give here is whatever the value
you want to give, like default value, what the default value you will give in the default fact. Here I've written a simple function called def value, and I'm returning not present. Okay, this is a function, and I'm here assigning the here I'm defining the dictionary d equal to default dict, and I'm passing the parameter as default value. So when the value is not present, then we will get the statement as not present. So here I'm trying to access print d of a, b, c. So a, b is present but c is not present. So in the place of c we will get not present. So have a look at the output, then you can let you know. So see here, a we got it as 1, b you got it as 2, but c you got it as not present. So this is how you will pass the default value or default factory value. So coming to the next one, you can also pass the default factory values as a lambda parameters or whatever you want you can pass. So here I pass the value as a lambda value. So you can see here lambda arguments I am passing here with the set equal to default lambda not present. So in the before example we wrote the function, right? So here I am passing the lambda as a default factory argument. So here a, b have given but c is not there, so you can see what output you will get 1, 2 and not present because I am passing with the help of lambda. So in case we are not present, we are not here going to give this default values, so you will raise a key value error. So you can also give this missing method. What is this missing method is, it will provide the default value dictionary, and this function takes the default value as an argument. So it will give the default value, and if the argument is none, then you will get a key error. And by default it will take the get item. Basically it is called by the get item method of the dict class when the request is not found. If the request is not found, it will get. And get item raises or return sample. So here I am giving. So we can also pass this. So let us see with a simple example. So here I have given underscore missing underscore. So we know that this is having the special meaning. When we are going to give underscore, it will have the special meaning, right? So here I am passing the default with the lambda not present and d of a equal to 1 and d of b equal to 2. And print d dot missing. So here you will get the default value. It will provide the default value. If you are having the value also, you will get the default value as not present, like this. So this is for about missing. So next, coming to the next, using list as a default factory. So we can also pass. Just now we have seen with the help of function and with the help of lambda and all this, right? We can also pass with the help of 5. For that I have given here list equal to default dict of list, and then I am appending I here and dictionary with values as list. So let us see what you will get. So here 5 I have given. So since I have given 5, I will get 0 to 4, and I am appending here so that you will get 1 by 1 like this. So this is about so what I am going to do here is I can pass here list also. We can also give the list without the lambda arguments or with the function. We can give as a list. So the next thing is we can also use classing as a default factory values. So this is about class int. So how can we give it help of class int? Just like the normal things. So here I have given, here I am passing the int and L equal to 1, 2, 3, 4, 1, 2, like this I have given, and I am going with for I in L, and I am incrementing the value, and I'm printing the value. So I will get all this: 1 with 2, 2 with 3, 3 with 1, all this, 1 with 2, like this, 2 with 1, 2 with 3, 3 with 1, 4 with 2. So this is how you will get. So here I am going to incrementing here, and this is how you will get all the values. So we can also pass the values with class int or list or functions or lambda arguments, anything we can pass with the default factory values. This is a good default dictionary. That's all for this video. This session we are going to see about chain map. It is also one to one in the collections. So we will see about that. So we can also say that chain map is like a container, because it will encapsulate or it will bind all the dictionaries into a single unit, so that we can call it as a chain map. And we can also call it as a container, and those containers are called as a chain map. So this chain map is one of the member of the module called collections. So what are the operations which we are going to perform in chain map? Chain map is two operations, that is access operations and manipulation operations we can do. So in the access operations, what we are going to, with the keys of this operation, what we will do is, it will display all the keys, all the dictionaries in the chain map. All the keys it will display. And coming to the values, it will display all the values of all dictionaries in the chain map. So we know that dictionary is like a key and value pair, right? So with the keys, you will display the keys, and with the values feature, you will display the values. Whereas maps, the help of maps, you can display the keys as well as the corresponding values. So let us see with a simple example of that key and values how it is going to perform all those things. So let me copy this. So we will import from the collections, because as I have told you that it is the collections module, I am going to import collections, and I am giving the two dictionaries, DIC1 and DIC2, and here I am giving the value A1 and B2, B3 and C4. So you should observe that here I have given B2 and here I have given B3. So the same values I have, same keys I have given. So what it is going to do, you should observe that. So the next thing is I am initializing the chain map here like this, like chain equal to collections dot chain map. So from the collections I am using, that's why I am using collections dot chain map of both the dictionaries. I am using DIC1 and DIC2. So next I am printing the maps. So chain dot maps. So if next thing is I am here printing the keys. Next I am printing the values. So here I will get the both keys and values. Here I will get only keys, and here I will get only values. So now let us see the output. What we will get with the help of this. So see here, with the help of map we got it as A1, B2, B3, C4. All the dictionaries we got. All the keys and values we got, right? And next, coming to the keys, you should observe that you are getting only one B, but we are having two B's here, right? So it will take only one B, and even for the value, you will get only the first value only. It will take only first value. If you are giving here 3, so now let us see here. I will give here like 5, and here I am going to give 3 as it is. So you will see that you will get only 5, because it will take only the first value. So see here, you are getting only 5. So the dictionary, if you are having 2 B's or n number of B's or n number of B's, first entry. This is how the key accessing, you can access the keys, values and map. Next we can see how to manipulate the manipulation operations. We will see how to manipulate the chain map. So to manipulate the chain map, here we will go with manipulation operations that are, first one is new chain. So new chain and reverse, these are the two manipulation operations If you want to keep a new chain, if you want to add a new chain, so with this operation, with this method, you can add a new chain and you will add at the beginning of your chain map. The new dictionary you can add at the beginning of the chain map. You can also reverse the chain map by using reverse method. So these are the two operations which we can perform. So we can manipulate, we can add a new chain, we can manipulate operations. So here I have imported the collections and I have given 3 dictionaries. So I am initializing 3 dictionaries. But here I am using 2 dictionaries only. I am initializing the chain map, I am using only 2 dictionaries. After that, because we should know the difference before insertion and before adding the new chain and after adding the new chain. That's why I have given here initializing 2 chain maps, initializing 2 dictionaries here. And after that, I'm printing here maps. Key, it will print both the keys. And so, what is this new chain? New chain is DIC3. DIC3 is this new dictionary. So, with this new chain, it will add this dictionary at the beginning of your dictionary, beginning of the chain map, right? So, let us see the output, how it will come. And then, here I'm printing chain1.maps. So after adding, I have initialized with, I've given this with chain1, right? So here I'm giving chain1.maps. That means all the 3 we will get. And then value associated with P before reversing. Before reversing is like before values you will get. B value before is, what is their first value? It is 2. If I reverse that, what you will get? B value, you will reverse it. So you will get the 3 here. So after reversing, you will get n equal to what? After reversing, you will get the value as chain1 of B is 3 like this. So now let us see the output. What we will get? Our estimation is correct or wrong in the analysis. So here here I have given 2 dictionaries, DIC1 and DIC2. So I got 2 dictionaries. And I am displaying the new chain map here. And displaying the new chain map. Chain1 dot, because I have added the new chain here and I am accessing chain1.map. So I got new chain at the beginning of the chain map. And then value associated with B before reversing is 2. Before reversing is 2. And after reversing it will go up and then we will get it as 3. This is how the manipulation operations and access, we can also access and we can also manipulate the chain maps. So that's all we're going to say about name tuple. So we know that name tuple is also the module which comes under collections. So in the collections module we will see what is the name tuple and all. And this name tuple, Python supports the type of containers, right? Different types of containers. And one of the container is name tuple, which is under the collections module. So what is the difference between dictionaries and this name tuples is, so like the dictionaries, it will also support keys and values and all those things, but only the difference is, whereas the dictionaries will support keys and values and named tuples will support both the access from key value and also iteration. And this is the only difference with the dictionaries. So let us see what are the different operations in name tuple and how it is different. So different access operations are accessed by index and accessed by name using get attribute. So these are the 3 different access operations. So access by index, as the name itself we can say that it will access by with the help of index values. That means we will have index values starting with 0, 1, 2, 3 like that, right? So we can access the values with the help of index. But in the dictionaries it is not possible accessing the index values, right? So we can also access with the help of key names, and we can also access with the help of this get attribute method. With this get attribute method, we will pass the attribute values. So with that, we will get the value. So let us see with the help of an example so that it will give you a better way. So I will import this from collections module and I will be clearing the named tuple like this. Student equal to collections dot named tuple and student. This is the name. And I'm giving here keys as name, age, and DOB. And here I'm adding the values of the named tuple. DOB is 25 to 90, so 97 like this. And I'm accessing. So we have seen that we can access the values with the help of index, with the help of name, and with the help of get attribute, right? So here I'm accessing the value of S of S1. S1 means 19, right? And here I'm using with the help of index. Here I'm using with the help of key name. These are the different key names, right? Name, age, and DOB. So I'm accessing with the help of key name, and here I'm accessing with the help of get attribute. So I'm passing the attribute as S, DOB, that means date of birth. So let me see what is the output that we get. So for S of 1, I'm getting 19. 19 is the first index. So this is the 0th index, first index, and second index, right? So first index I'm getting. And then I'm getting the key name S of name, S dot name. I'm requesting S dot name. So what is the name here? I pass the name as name. So I got it as name. And I'm using get attribute S of DOB. S comma DOB. So I'm getting DOB. So let us change this to 2. I will change the value to 2. So let us see. So okay, let me change this also to name. So let us see what we will get. So see here, with the help of index, I am getting the value here. S of 2 is date of birth and key name is 19. Here, what is this? And I am requesting here age, so I am getting 19. And here I am requesting age, so I am getting name. I am getting name as 1. So this is how we can access the values of the named tuple. So next thing is conversion operations. So we can also convert, like, see how can we convert. There are 3 different operations. So underscore make. What does this underscore make is? It will return a named tuple from the iterable or past arguments. So how we will see in a while. And underscore asterisk, it will return the order dictionary. However, we are passing the order dictionary, you will get the same way. And using double asterisk, using double star. So what is this using double star will do is it will convert the dictionary to named tuple. So let us see this with the help of example. So how we will do? Let me show you. So you can see here. Here I am declared 1, and here you can see here I am initializing the iterable with li, and I am passing the values for this. So here I am adding values, here I am initializing iterables, and here I am initializing the dictionaries. So we can require that it is a dictionary, right? This is a name and value, key and value base. So this is one. And then here I am using student of make. That means I'm using the make operations here. So what is this make operations we have seen here? It returns the iterable. It will access the iterable. So as we have given student underscore make, student underscore make line, so it will access this iterable. And here I'm accessing as so order dictionary. What it will return the order dictionary. What is the order dictionary? First I have given. So this is the first I have given. So this is how I will get the order dictionary. And then star vi. That means whenever we are using double star, so what it will do, it will convert the dictionary into a named tuple, right? So this is a dictionary I have given, so it will convert into a named tuple. So let us see the output what we will get. So first iterable is li, right? So I will get these values. And order dictionaries using named tuple is, so with the the help of named tuple, and I'm using as dict. So first I'm passing Nandini and all these named tuple. So I will get these named tuple according to the order dictionary, and I'm using star star di. So it will convert the dictionary into a named tuple, and then you will get. So see here, I passed here as a dictionary, but I got it as a named tuple like this. So this is how you will convert the operations, and also we have some more additional operations, that is field and replace. So what is this field will give is it will return all the key names, whatever we have declared, it will return all the key names, and replace will replace, it will change the values. So how all those things, let us see. Replace and field. So here I have given, here I have declared the name tuple, here I am adding the values as we have discussed in the previous example, for example, and here I am using s underscore fields. So here what I should expect, whatever the fields, whatever the key names I am giving, I should expect these values, right? And then next I am replacing the value. Whatever I am passing here, I am replacing here with some other name. So with the help of replace, it will replace the name, and with the help of fields, we can get whatever the fields we have. This is about this fields and replace. So let us see the output, what the output we are getting. So here, as I have requested s underscore fields, so whatever the fields I'm requesting here, I can see the name. So actual name is Nandini, and once I replaced, here I will get the replaced name. So if I pass here one more value like after tup, I am placing here as place. Let me show you how you will get. So I am placing here place, and I am running it again. So you will get the error because here it is not enough. So let me, I will give HYD some place. So see here, now you are getting place as well. So this is how you will get fields. If you want to change the name also, you can change this name, or if you want to change place. So if you want to replace the place with the place Hyderabad with some let it be India, Hyderabad with India. So how you will? So you can see here, observe the difference here. So you are getting some error. Sorry, and here I have given in place. So this is not existing. So see here, place is changed to India. This is how you can replace, you can get this. So that's all for this. Hello everyone, welcome back to Heapqueue. So we will see what is Heapqueue and what are the different operations we are performing on Heapqueue. Like insert, delete, that is called pop, and insert, append, all those things. How it is possible, we will see. So you know that queue. So while we are going to some shops or malls or bill counters, so we can see queue. That means a large number of people are there. So what is the criteria? What is the condition they are following? Those who come first, they will get the services first, right? So in the same way, here also queue will follow the same thing. First in, first out philosophy. We will learn that for the queue data structures. So it will follow first in, first out. Whether it is copying or inserting, it will follow. For copying, it will follow first in, first out. So in the same way, let us see for the Deque what it will do. See what it will have. So as we are naming it as a Deque, D means two ends. So the first end and the second end. So this is the first and this is the second end. We are having the two ends. So we are also having two rays as well as two fronts. So we will have two rays and two fronts. So when the item, if we want to insert or if we want to pop, we can pop from both the sides. That. So this is what about Heapqueue. So in this Heapqueue is from the collection. It is a module from collections. So Heapqueue is preferred over list in the cases when we need quicker append and top operation because it is easy from both the ends. We can remove or we can insert. It is easy with the help of Heapqueue while comparing with the help of list. So the Heapqueue, the time complexity of this Heapqueue is O of 1. When comparing to the list, it is O of n time complexity will provide. And coming to the operations on Heapqueue, what are the different operations it will provide is, as I have told you that append is inserting or adding. So it will insert by default the right end of the Heapqueue. That means the side it will insert. If you want to insert from the left side, we are having append left. We are having a function append left. If you want to remove, by default it will remove from the right side with the pop function, and if you want to remove from the left side, we have pop left. So let us see this with the help of a simple program. So first of all, we will import collections because this is from collections module. So we will import from the collections and then we will initialize the Deque here. We will initialize the Deque like this. Deque equal to any variable we will give. T equal to collections.deque of 1 to 3. So you should initialize the Deque in this way. Any variable that is equal to collections.deque and 4 in the right side. So I am writing de.append of 4. So it will append in the right side. And then I am printing the whether I should check whether it is 4 it is appended or not. So I am printing here print de. And then I should append from the left side. So de.append left of 6. On the left side I should append. Then I am printing the values here. Print de. Then after that I am popping de.pop. That means I want to remove the element from the right side. So I am removing with the help of this. And I am printing here print de. Then pop left. And from the left side I want to remove one element. After that, I am printing the values after deleting. So let us see the output what it will give. So see here, after appending 4, we will get 1, 2, 3, 4, right? And then after appending 6, the left side you will get 6, 1, 2, 3, 4. And then after deleting from right, you will get 6, 1, 2, 3, so 4 is deleted. And after deleting from left, you will be deleted with 6. So you will be having 1, 2, 3. This is what about appending and deleting from the Deque. So we can delete and we can append from both the sides. That is what Deque. So we can also perform some more operations like index. So we can also give the index value here, index element, whatever the element you want. So for example, if I want the element called 5, so I will give here element is 5 and from the beginning position and the ending position. These are the which occurrence it is there. Like first the index element, it will give you the index element, the index number, the first index of the value mentioned is argument. So it will check for this, what is the index position of this element. Let's insert I, a. So it will insert in that particular location, whatever the key, whatever the element, whatever you are mentioning here, index I. So it will be I is the index and A is the element. So it will add in that position. Then remove. It will remove the element. Which one element, and then count. So count is nothing but how many number of times the value or the index is there. Sorry, how many number of times the particular value is repeating. So it will count that many number of times. So let us see this with the help of a simple example. So let us see this. So we will insert collections and then we are initializing the Deque, and after that I'm writing index. So I want to search fourth value, so fourth element. So where is the fourth element? Here is the fourth element. So beginning position is 2 and from the ending position is 5. So because there is 2 occurrences here, so I move from 2 to 5 only. So that's why I'm mentioning 4, 2, 5 will keep the first occurrence position, and then I'm inserting 4 in the fourth position. I'm inserting 3. So where it will be inserted before this? So 0, 1, 2, 3, 4. So before this it will insert. Then I'm printing the Deque, that means number of times 3 is, and I'm removing the 3. The first occurrence it will remove, not the whole 3. Only the first occurrence. What is the first occurrence here? This was the position. So it will remove this 3. And it will, I'm trying to print the Deque. That means I'm trying to print the remaining values. So let me run this program. See the output. So the number 4 occurs at position 4. 0, 1, 2, 3, 4. Yes. And I'm going to insert 4, 3. So I'm going to insert 4, 3 here. So in the fourth position I have inserted 3. And I'm going to count how many number of 3's. So you can count here 3 times 3 is there. And then I'm going to delete the first occurrence of 3. So the first occurrence I'm going to delete this 3. 1, 2, 3, 3, 4, 2, 4 divided. So this is how you will count and indexing, all these things you will do. And also we can do some more operations like extend. So we have appended one value, we have deleted one value like that. But we can insert, we can append more than one values, multiple values we can append. This is from the right side we can append with the extend function, and from the left side we can append with extend left. And reverse is the function where we can reverse the elements, and rotate is also possible. Rotate means how many number of elements you can rotate. We can rotate that number of elements. For example, if I want to rotate 3 elements, so if it is in the right side, it will go to the left side with that 3 elements. So we will see this with the help of the example so that we will understand it better. So let me copy this code. So very sorry. So this is how we will do. So D equal to collections.deque. Here I have given 1, 2, 3 is Deque. Extended 4, 5, 6. That means here I can expect 1, 2, 3, 4, 5, 6. Here I printed DE and extend left. So from the left we will extend. From the left we will get 9, 8, 7 like that. And then here I'm printing here, and then here you can observe here. This I'm rotating -3. So the three values it will rotate to left. So here I have given minus. So it will rotate to here after the rotation, and then reversing. You can also reverse the elements. The whole elements will be reversed. So let's see this output what it will give. Let me run this. So this is the output. So the Deque after extending is 1, 2, 3, and here I have extended 4, 5, 6. So it's okay, 1, 2, 3, 4, 5, 6 we go. Then after that, extend left 7, 8, 9. So you can see 7, 8, 9 here. So after rotating, so what I have rotated? I have rotated -3. So -3 means you can see here how many it is rotated. 9, 8, 7 went to right side. So this is what the rotation, and reversing is see here from right to left. 7, 8, 9, 6, 5, 4, 3, 2, 1 like that. So let us give here +3. What it will happen you will see here.
means 3 elements will be rotated right side. So you can observe here. So 4, 5, 6 has come here. 4, 5, 6 is come to the left side. So this is for right rotation and left rotation. So this is how to extend the values from the left side, how to rotate all these things, right? Here about Userdict in Python, you just bring user list. These are from the collection module. And what are the different things it will perform and what are the uses of that we will see. So Userdict in Python, this is an unordered collection. We know that dictionary is an unordered collection, right? So this is like same as dictionary in Python, and it is used to store various different values, different data values. Unlike the other data types, if they are considering the other data types, it will store only a single value, whereas dictionary will store in key value pair, right? So key value is provided in the dictionary, which will give more optimized values, which is more optimized values, right? So in the collections, in the Userdict, we will use collections.userdict because it is from the collections module. So we will call collections.userdict. And Python is also supports a dictionary like container, and this is from the collection module. This class will wrap all the contents of the dictionary. It may be objects or it may be elements, whatever it is. It wraps around the dictionary objects. And what is the speciality of this is we can create our own modified functionality and with adding the new behaviors, all these things we can do with this. So the syntax of this is collections.userdict initial data. So let us see the example how we are going to do. So in this example, I am just creating a simple dictionary and also I am creating a empty dictionary. So let us see how we will create. So from the collections I imported Userdict and I have given here dictionary keys and as well as values. Keys are ABC, values are 1, 2, 3. And coming to the Userdict here, I am creating a user dictionary userd equal to userdict.d, and I am printing here userd.data. So whatever the data I am providing, it will print that data. And I am creating an empty dictionary userd equal to userdict and userd.data. See here I am not passing anything. If I pass here the dictionary, we will get the dictionary data again, but I am not passing anything, so that it will create the empty dictionary. So let us run this program. So you can see the output. You will get the dictionary A1, B2 and C3, and here you will get the empty dictionary. This is how to user dictionary. And also we can see some inheriting and all those things, how the inheriting possible here. And will it allow the pushing, popping, that means inserting and removing in the dictionary? You can see here. So in this example you can see. So here I am writing the class. First I am importing and I am writing the class mydict with the argument mydict, and I am writing the function. We know that if we are writing underscore, it is having a special meaning, right? We have already learned about that. And I am passing a message called deletion not allowed. And here I am writing the pop and I am raising the error deletion not allowed. And pop item I am writing, and that means here I am stopping to what I am telling here is I am stopping to remove do not remove the elements from the dictionary. That's what I am going to tell you. So here is a driver code. Here I am creating the dictionary, and here I am printing the statement original dictionary and I am printing the D. So here I can print the dictionary list, and here I am trying to delete the element pop-up 1. I am trying to remove this element. So while I call this, you will go to the pop function here
and it will give you the message runtime error deletion not allowed, because here we are trying to stop the deletion. We are trying to we are trying to stop the deletion. So you can see here, I got the original dictionary, and while I am popping here, I got the raised runtime error deletion not allowed. This is what I got. So this is how you can work with the dictionaries, Userdict in Python. And coming to the user list, so similarly we can also create the user list and user string as well. So in the user list is list is nothing but it is an like a data structure. It is like it will be unlike only homogeneous, right? And it may have a single list may contain data types like integers, strings, whatever it is, right? Integers, strings, objects, values, whatever the values you can give. And the main thing is the list will consist of indexing. The value indexing will start from 0. That is what the list. So in the here collections.userList we will use because it is from the collection module. And if this class acts as a wrapper class, it will wrap all the things. Whatever if you want to create a list or you want to create an object or whatever, it will wrap the objects. And the main benefit here also is we can create our own modified or with the new behavior list we can create. That is what the main advantage in these collections. So how it is possible? So collections.userList.list is the syntax. So let us see a simple example here. Here I am creating the list with the list and also the empty list I am creating just like as a dictionary. So let me show you. So you can see here list equal to 1, 2, 3, 4 have given, and I am creating a user list user L equal to user list of L, and I am printing the data. Whatever the data here I passed, I am printing the data, and here I am printing the empty user list because I did not pass any arguments. So you can see here. So I got 1, 2, 3, 4, and I am passing the empty list. This is what about the user list. So again in the user list you can see if the deletion is possible, insertion is possible or not. So you can see here. So here you can see I am creating the class with my list, and I am creating the function definition of remove, and I am raising the error to stop the deletion. Here also I am raising the error to stop the deletion. Here is the driver's code. I am passing the list, my list of 1, 2, 3, 4 is original list. I am printing here, and I am trying to append the list with the value of 5. I will get 1, 2, 3, 4 and 5. And after insertion, what is the list? What is the list here? It is here I will get 1, 2, 3, 4, 5 because here I appended 5. So I am giving here L, and I am trying to remove. So if I am trying to remove, what it will go? It will go here remove, but the remove I am raising the error here. So you can see here after insertion you are getting 1, 2, 3, 4, 5, and I am getting runtime error deletion not allowed. So this is how you can do with the list. So next we are also having strings. So in a similar way we will do for the strings also. Strings and characters we have in other languages. So strings is nothing but the collection of characters, whereas character is a single alphabet. We can tell that the character is a single alphabet or a piece of. We cannot tell piece of a string because it should be only one byte data. So it is a single character. So in the string we can see here. This example I have given just how we are passing the string in Python. Here I pass the string welcome to the coding class by Swetha, and I am printing here string with I am using here single quote. You can see here. So that's why I am telling here string with the use of single quotes. Here I am using double quotes. I am telling string with the use of double quotes. So you can look here. So this is how the string string. This is how it uses the string, right? So next one is next thing is we can also pass like appending or deleting. How it is possible? So collections.user string sequence. This is the syntax, and here I will see here how to append or how to delete the string. So here you can see, here I'm passing as a string d, but here I'm assigning d equal to 1, 2, 3, 4, 4. User is equal to, I'm assigning here user string of d. I'm creating a user dict and I'm getting the value of d here. And here I'm creating the user dictionary and I'm requesting to create the user empty dictionary. So I will get the empty dictionary as like as I have seen in the dictionary and also list, right? So here you can observe the value 1, 2, 3, 4, 4, and here is an empty dictionary. This is how you will get the string, and then we can see whether the strings will append or remove. Is it possible with the strings or not? So let us see that. So here we can see that I'm creating the class. So for everything we will create a class here. So we will create a class and we are going to write the function. Here I'm writing the function called append. I'm appending the value s here, and I'm appending the value as whatever the string I'm passing here. I will append with s here. Whatever the string we are passing for remove, it will be removed with that string. So here I'm passing the value as a string is coding tricks. This is the original string, and after appending yes, here you will get appending. After removing e from the string, let me remove yes here. Let me remove yes here. So after removing, what you will say? See here, I'm calling append of yes. So append this function. So it will append the original string with yes, and I'm removing yes. I'm going to remove the original string with yes. So this is the original string coding tricks, and after appending yes, this is the yes, and after removing, this is the coding trick. So you can observe the difference. Coding tricks, yes, I appended. Remove yes here. This is the original string. This is how good in a collection module. That's all for this. Hello everyone. Welcome back to coding tricks. So Heapqueue. So Heapqueue is one of the data structures. We can say that it's a data structures. And what is Heapqueue and what are the operations which are going to perform in Heapqueue? We'll see now. So Heapqueue is nothing but it is like a priority queue. So you may have a doubt, what is a priority queue, right? So priority queue is nothing but when you are going to any of the shopping malls or any in the cinema theater or anywhere, so you will see the queue, right? So if you have seen the queue, or if you have seen the queue, so what you will see, like if you are seeing one of the handicapped person or if you are seeing any of the disabled person, so you will feel pity and you will be giving first choice to them, right? So in the same way, the priority queue is also like we will have certain priorities. So we will give some priorities in the queue. So that is what the priority queue. So by externally the user will mention the priority. So this priority this heap data structure is, will represent the priority queue. So in Python, Heapqueue is from the Heapqueue module we will get the Heapqueue. So Heapqueue. From this module we will get Heapqueue. So and if you are writing the data structure in Python, pop out the smallest element of the queue. That is the minimum heap. Whenever the elements are pushed or popped, we can see the heap structure is maintained. And if we are doing heap of 0, it will return the smallest element, that is the minimum element from the heap queue. Always it will return the minimum element. So what are the different operations on the heap we are going to perform? Let us see that operations. So first operation is heapify. So what is this heapify means? It will convert the list or anything into a data structure called heap data structure. So that means it will convert it in the heap order. Let's come to the heap push. Heap push will take two arguments, that is heap and EL. EL is element, heap and element DD. So what it will return is it will push the elements. Whatever the elements you are passing from these arguments, it will insert or push the elements. It will adjust according to the structure which is maintained. That means if it is maintained in the this ascending order, so the element will be fixed in that order itself, whatever the element you are inserting here. Then coming to the heap pop. Heap pop is removing or popping the element. So in the same way, here we will give the element. So whatever the element we will give, so it will pop from the list or the heap structure. So this is what about the operation. So let us see with simple program. So this is the simple program. So all these operations we will see now. So we are going to import Heapqueue, Heapqueue, and then I'm going to give the list here. Li equal to 57913 given, and I'm going to call heap.heapify of Li. So heapify, what does a heapify will do? This list will be converted into heap order, right? And then here I'm printing what is the list, what is the order which we are giving here. And Heapqueue dot heap push. I'm writing heap push, that is Li of where it will be after 1 and 3, the element 4 will be in the order, right? So it will give 1, 3, 4, 5, 7, 9 like that. And then next is modifying the heap. How to modify? Sorry, here we have already inserted, right? So here after modifying we are printing the elements. Then here heap.pop of Li. So when you have seen the heap pop, it will remove the lowest element or the smallest element from the heap. So the one is the smallest element, right? So it will remove 1. So you will see 1 over here. So let us run the program. So let me see the output. What we will get. So this is the output. So the created heap is 13975 like this, 13975. And then the modified heap is, so you will get here the modified heap in the order 134759 like this, 134759. Okay. So then the top and smallest element is 1. This is the smallest element. This is how we will do the operations with the heap. So apart from this, we will have some more operations like heap push pop. So heap push pop will take the arguments heap, element. So not only one element. So just now we have seen only one element, right? Pushing only one element like that. So here we can put the function of both push and pop operations. Both the operations are carried out here. And also that it will increase the efficiency because both the pushing and popping, that means inserting and removing, both at a time they are taking. So it will increase the efficiency. Here it will maintain the heap order is maintained after this operation. So after pushing and popping, heap order is maintained. Then next, heap replace. So heap replace, as the name itself tells that it will replace the element, whatever element we are giving, it will replace the element. So let us see this example. Let's see the program.
So let us see with the help of example. So what we have said here, heap push pop and heap replace, right? So here we have given two lists, and here I have given heapified alignment. That means it is converting the list into heap. Here also it is converting the list into heap. Then push pop of li1, 2. Here heap replace li2, 2. So what heap replace will do here is it will push and pop simultaneously. Both the things it will do. So it will replace. So here heap push pop is it will take both the items like pushing and popping here also. So it is both are not same. Heap push pop and heap replace are not same. So we will see what it is. So let me run the program. So the popped item is using heap push pop is 2. Here it is inserted and heap replaces 3. So here we have given 2, right? So after 2 inserting 2, what it will be? So 2, 3, 4, 9, 7, 5, right? In this order it will come. So it will be inserting, right? So after 2 it will be 3. So the second element here is 3. That's why we are replacing. So that's why we got it as 3. This is what about heap push forward replace. So here we can see that here replace will return the smallest value. Replace, that is the only difference. Replace will replace the smallest value originally in the heap, and the above function heap push forward will return the largest value. That is what larger value which is pushed. So that is what the difference. So some more operations are there like n largest and n smallest. So n largest will give you the largest number which is giving here as a key. Here I am giving key equal to 1, right? So whatever the key is mentioned, it will return the k largest element. Here it will return the k smallest element. So let us see the help of a simple example here, so that it will get through. So here I am giving here print 3 largest numbers in the list. So here I have given already the list. This is not the list, and here I converted list into a heap, and then here what I am doing is n largest 3, 11. So whatever the largest value from this 3 largest values I am requesting here. Whatever the smallest values here, I am requesting 3 smallest values from this. So let us see the output. So this is what 10, 9, 8 are the 3 highest values from this, and the lowest values are 1, 3, 4. So if I change here, what I will get, you can see. I am giving here n smallest 4. So you can observe here. So I will get 4 smallest values, and 4. If I change here 4, I will get 4 smallest. So 4 largest values. So this is what about Heapqueue. We can perform operations like inserting, deleting, that means pushing, popping, and then we can also get the largest values, smallest values, and all the things we can do. With the help of Heapify, it will convert the list into a heap. So this is about heap. That's all for this. Subscribe. Thank you.